So last lesson we looked at how to find the sum of a geometric series, and we came up with this formula. This is a formula that will work every time, no matter what r is, but we also know that if r was less than 1, there's an alternate version of the formula where parts of it are just switched around, and this just makes the calculations a little bit more straightforward. Now we can use this every time, but what we're thinking of today is what happens when our sum approaches some sort of limit. Now this actually only happens when our ratio is between -1 and 1. So if you imagine a ratio like that, let's jump down to this example at the bottom. Let's imagine a series where we have r being a half. So to get each term, we just multiply by a half. The numbers are going to get smaller and smaller. And this would happen whether we had a ratio of positive a half or negative a half. Let's look at one that might be negative a half. We'll get the same numbers, but they'll alternate in signs if our ratio is negative. So we'll get this sort of situation. Now, whether we have them all positive like this or every second one being negative, what we're adding each time is a smaller and smaller and smaller number. And if you're eventually adding numbers that are so small they'll barely add up to anything, then your sum is going to approach some sort of limit, and we can easily find out what that is. Now, we could keep on using this formula all the time and we'd come up with the right answer, but there's more information in here than what we really need. So let's look at this example at the bottom to see how it works. We've got here a series where the ratio is a half. So to get between each term, we just multiply by a half and we get the next term. But if we look at the sum to n terms, the sum of the first one term is just 1. The sum of the first two terms, we need to add 1 to half and we get 1 1/2. The sum of the first three terms is 1 3/4. And going up 1 7/8, 1 15/16, 1 31 32, 1 64, 63 64. We've got a pattern there, don't we? We've always got 1 and something. And the something is becoming a fraction that's getting closer and closer to 1. So what we're looking at then is if we kept on going here forever, would it get up to really high numbers? Or is it actually approaching something? Now it looks like it's approaching 2, doesn't it? We're always going to have 1 and something, but never quite another whole one. So then applying one of these formulas to this to find the sum to n terms, if the ratio is half, it makes sense to use this one. The sum to n terms is our first term, 1, multiplied by 1 minus our ratio, which is a half, to the power of n, all over 1 minus our ratio. Okay, let's tidy this up. So the sum to n terms is, now if you've got, let me just put this over on the side here, if you've got a half to the power of n, isn't that the same thing as 1 to the power of n over 2 to the power of n? And 1 to the power of anything is just 1, isn't it? So I could really just write it like that. So I'm going to tidy up this second part like that. On the bottom, I'm going to have a half. Now, if you divide by half, that's exactly the same as multiplying by 2. So up here, we're going to have 1 multiplied by 2. That's 2. That gets rid of our fraction, doesn't it? We've divided by a half now. And then in the brackets, we've got 1 minus, and I'm going to use this simpler version of that fraction. All right, now let's think what's going to happen as n approaches infinity. Our sum of infinity number of terms, if we write it like that, is going to be 2 times 1 minus 1 over 2 to the power of infinity. Now, 2 to the power of infinity is obviously infinitely big, but 1 over an infinitely big number is virtually 0, isn't it? So what we're going to have here is really just 2 lots of 1 minus nothing. 1 minus 0 is just 1. So really, we're going to approach 2. So what we can say is that our sum is going to approach 2, and that's exactly what we expected by just looking at the table of values and having a bit of a guess. Now, when we're counting, we can never actually get up to infinity, can we? So if we're finding the sum of an infinite number of terms, it might approach 2, but just as we can never get up to the infinite term, we can never actually get to a sum of 2. So there's 2 ways to think of this. You can either write the sum of an infinite number of terms is 2, knowing that it's impossible that you'll actually get there, Or you could say as n approaches infinity, the sum to n terms approaches 2. And here we use an arrow to symbol that it's approaching something, but it's not actually getting there. Now, looking at the parts of the formula that we're not really going to need if we've got a ratio that's between -1 and 1. Well, if we've always got a fraction here, something that's less than 1, and we raise it to a power, as that number gets really, really big, the power gets really, really big, this whole fraction is going to always tend towards 0 when we have a ratio in this area. So this whole part of the formula becomes quite unnecessary. So the two most common ways to write the formula that we're left with, if this part becomes 0 and we've got 1 minus 0, we've just got 1 times whatever was up here. And remember, this is just an a. So all we really need then is we need the a and we need the 1 minus the ratio. And that's what we have here. Now you can say that the sum of an infinite number of terms is equal to this formula, knowing of course that if you can never actually get to an infinite number of terms, you'll never get to this number, but it is actually the limiting sum. And that's a notional sort of idea based on infinity that you need to keep in mind. Or it can be written this way, which basically says the same thing. It just says the sum of n terms. If we take the limit of it as n gets really, really big and approaches infinity, it's going to equal this. But of course, this whole thing only happens when r is between 1 and -1. Some example questions now. In the series 18 plus 6 plus 2 plus a whole lot of other numbers, explain why this one has a limiting sum and then find it. Now, you first need to work out what r is. That's the number we're multiplying by to get to the next term. And you can do that by just taking this term and dividing it by this one. Well, 2/6, that's a third, and that's the same as 6/18, which is also a third. So really, the answer to the first one is just that r is equal to a third, and this is between -1 and 1. And that shows your knowledge there that therefore it will have a limiting sum. Now let's find the limiting sum. Well, the sum of an infinite number of terms here is going to be this. Write the formula out each time so that you get really familiar with using it and you'll remember it. Now the first term is 18, so that goes up the top, and we have 1 minus the ratio, and so we end up with a limiting sum of 18 divided by 2/3, which is the same as 18 times 3/2, and so you should have there 27. This example is asking a question around the other way. Find the ratio of a GP. If we know the first term is 10 and the limiting sum is 40, so thinking about what you already know the sum of an infinite number of terms is 40, and you know the first term. So if your formula is like this, then you already know that this side is 40, and here you have 10 over 1 minus r. So now you just have to solve this as a little linear equation. Multiply both sides by 1 minus r. I can see that I can divide both sides by 10 straight away. And now I've got 4 minus 4r is equal to 1. So that means 4r must be the same as 3, so r is 3/4. And sure enough, just double check that your answer is a number between -1 and 1, because if it wasn't, then this thing wouldn't have a limiting sum. Now the trickiest types of questions that you can get in this topic are ones like this, where it's not immediately obvious what you need to do. For what values of x does this series have a limiting sum? And then we need to find the limiting sum in terms of x. Now if you're not sure how to start, just write down what you know. Start by thinking, well, what is the ratio here? What are we going up by? What have I multiplied 1 by to get x minus 2? Well, I've multiplied it by x minus 2. And look, I've multiplied by x minus 2 again. So we know that r is x minus 2. Now we want to find the values of x that would make this thing have its limiting sum. You only have a limiting sum when r is between -1 and 1. So if you know what r is, you can just sub that in and say x minus 2 has to be between -1 and 1. Now how would you know to do that? Well, just think of what you know about GPs that have limiting sums and think about what you know about this one, combine the two things together. Now to solve for x, just add 2 to each part of the inequality, and we know that x must be between 1 and 3. So we've answered the first part, x must be between 1 and 3. What is the limiting sum in terms of x? Well, the limiting sum will be a over 1 minus r. And so we know what a is, it's the first term. And we know what the ratio is, it's x minus 2. So we have this. Now you'll need to be careful not to make a classic sign error here, because on the next line we've got 1 over, and this is 1 minus x plus 2. So we'll actually have 3 minus x on the bottom. And that's the limiting sum in terms of x. They've asked for it in terms of x. And there's no point subbing in values here because we'd have a whole range of them. And that's not what we've been asked to do.